Section 4, we move away from multiplication and we go into division. So we've had multiplication properties, now we have a division property. So to show you what the property is before I actually teach it to you, see if you guys can develop the property yourselves, I want to write this 4 to the 5th divided by 4 to the 3rd out, and then we'll see what happens. So 4 to the 5th is actually what? Not the number, write it out. 4 times itself 5 times. Right. Now the denominator is going to be what? 4 times 4 times 4. Well, now the way that that's written, what do you notice? Yeah, there's like a bunch of fancy ones here. 4 divided by 4 is 1. 4 divided by 4 is 1. 4 divided by 4 is 1. And what am I left with? 4 to the 2nd power. So let's take a look at the other one over here with a variable this time instead of a number. I want to write this one out as well. What am I going to write? X times x times x times x times x times x times x divided by x times x times x times x. And you already see what the answer is going to be, but I want to finish this off. So what do we have here? A bunch of fancy ones that divide out. So x divided by x is gone, x divided by x is just 1, x divided by x is 1, x divided by x is 1, and I'm left with what? X to the 3rd. So based on these two results that we just found, what can we say is going to be true about when we're dividing like bases? You subtract the exponents, that's right. Notice that the bases here were both 4. We had 4 to the 5th divided by 4 to the 3rd, and we wound up with 4 squared. The bases here were both x. We had x to the 7th, we had x to the 4th, and we wound up with x to the 3rd. How do those exponents relate to each other? Well, 5 minus 3 is 2, and 7 minus 4 is 3. So it seems like when you divide like bases, you subtract the exponents, and that's absolutely true. So here is that actual property officially. To divide powers with the same base, subtract the exponents. So that's our new rule for this section. Officially, the algebra, a, our base, to the whatever exponent that is, divided by the same base to some other exponent, you subtract them, m minus n, and that's what they're saying right there. And as usual, a can't be equal to 0 for this whole chapter. We've been talking about that. And m and n are rational numbers, and rational numbers are what? Ratios. So like fractions and integers. Good. So for example, we have 2 to the 6th power divided by 2 to the 2nd power. We subtract those exponents. 6 minus 2 is 4, so we wind up with 2 to the 4th power, which we know is what? 16. Good. X to the 4th divided by x to the 7th, we still do 4 minus 7, the top number minus the bottom number. 4 minus 7 gives me negative 3. So I have x to the negative 3rd power, but I can't have that as my answer. I have to go 1 over x to the positive 3rd power, and then that is my answer. So it is possible to do this division, subtract your exponents, and wind up with a negative number. And then you have to remember how to handle that. And finally, is it 3/4? S to the 3/4 divided by s to the 1/2. What's 3/4 minus 1/2? 1/4. Think of quarters. 3/4 minus 2/4. 3/4 minus 1/2 gives you 1/4. So s to the 1/4 is the answer. Now this little step right here, what they were doing was making a common denominator. Because in order to subtract, just like in order to add fractions, you have to have a common denominator. So watch out for that. So that's if you have just a couple of things. Now what you're going to be given is a bunch of things being divided. You just divide the like bases, and then you write down your answer, and then you take care of negative exponents if you have any. So we have m squared divided by m to the 5th. What do we get? M to the what? Negative 3rd. It's 2 minus 5, which is negative 3. Top minus bottom. So we have m to the negative third. And then we have n to the fourth divided by n to the third, which is n to the first. Okay, so if we were done, we could just circle our answer. Are we done here? No, we have a negative exponent to take care of. So what happens to it? Okay, draw your division bar. N stays on top. M to the positive third goes on the bottom. All right, how about that next one? K to the sixth j squared divided by kj to the fifth. So we have k to the sixth divided by k, which is k to the fifth. J to the negative third. Good, I heard the j to the, but I didn't hear the rest. So j to the negative third. Are we done? Okay, so what do we do? K to the fifth on top. J to the third on bottom. Okay. And actually, I was about to do that right now. On this one, what do we have? I can't hear you. Oh yeah, sorry. I couldn't hear it with a pencil sharpener. So, what do we have here? X to the 0, which is 1. So I can write down x to the 0 for now. And then we know that that's 1. And then what? Good, that is y to the fourth. Usually people screw that one up. This is negative 1 minus negative 5. Negative 1 minus negative 5. What do we have to do to handle that? Keep, change, change. We're going to keep the sign on this one, change the subtraction to addition, and then change the sign of the last number. So now we have negative 1 plus 5, which is where that 4 comes from. So be very careful. This is where people make most of their mistakes, is with this subtraction that's going on here. Okay, and we got to take out that z. Yeah, z to the 7th. Okay, is that simplified completely? What do you see that we can change? Yeah, x to the 0, which is 1. So this turns into 1. I don't have any negative exponents, so I just need to write y to the 4th, z to the 7th, and I'm done. All right, how about this last one? What do we need to do before we're able to do this division? Yeah, we need a common denominator of my fractions. My common denominator is going to be 4. So this turns into y to the 3/4 still, divided by y to the 2/4. Now we can subtract. 3/4 minus 2/4 is 1/4. So y to the 1/4 is your answer. Is there anything else that we need to do there? There's no negative exponent. There's no numbers to simplify. So you're done. Okay, one more thing here, and then we'll get into doing some homework problems. Dividing with scientific notation. In the last few sections, every time we get to the end of the section, we've been seeing scientific notation. And we see that the scientific notation kind of follows the same rules of exponents that we've been learning. And the same thing is true here. So notice that we have a 10 to the 7th divided by a 10 squared. And we have a number here divided by a number here. So just like before with our scientific notation, when we had multiplication, we multiplied the numbers together and then we multiplied the tens to the power together and we added those exponents. Here we're just going to divide these two numbers and then do what with this? Subtract the exponents. So take 1.21 and divide it by 4.81. What do we get? 0.25 what? 9? Okay. Now times 10 to the 5th power. Now once we've done that, we have to make sure that it actually is in scientific notation still. Is this correct scientific notation? No, it's not. Because correct scientific notation says that the decimal has to go after the first digit. And that 2 right there would be the first digit. So this decimal has to move over one place to the right. 2.5155 times 10 to the 4th. Think of it this way. If I move the decimal 5 places to the right to take care of scientific notation completely, then I go 1, 2, 3, 4, 5. Here's the decimal. Now to put it back in scientific notation, I got to go 1, 2, 3, 4 to get it to where I want it to be. So that exponent has to be a 4. If you're moving decimal places to put things in scientific notation to the right, you take one away from the exponent each time. It's different than if you're moving it to the left when you're putting in scientific notation. So it's the opposite of what it was before. Okay, let's see if we can do this one. Yeah. Mm-hmm. Yeah, and I'll get to that in a second. So let's do this one by hand here. What do we do? Divide 7.33 by 4.33, and what do we get? Like that? Okay. Times 10 to the second. And the nice thing about this one is 10 to the second power don't even really need scientific notation. If I wanted to, I could move that decimal place 2 places to the right and then just write 169.284, and that would be my answer. It does say, though, to leave, it didn't say to put it in standard form, so we'll just leave it like that. But realize that this to the second power is just 169. It's very easy to switch that one. Okay, so let's take a look at the calculator and make sure we understand how to do this on the calculator. That's way too big. And I don't like it over there. So I'll move it over here. Let's go with that first one. I'm going to type in my scientific notation. So I got to type 1.21, and then what do I have to push? The double E button gives me my scientific notation. And then what do I type next? 7. Then divide by 4.81. 2. Yep. And then hit enter. And there you go. Now notice that the calculator, because it was a relatively small number, the calculator went ahead and put it in standard form for you. So that's fine, because you can handle putting it back in scientific notation if you need to. We're just moving the decimal over 1, 2, 3, 4 places, so we get the 2.51559 like we had, times 10 to the 4th power. And let's go ahead and do the last one as well. 7.33, the double E button, 6, divided by 4.33, the double E button, 4. Enter, and it did give me the 169.284 instead of the scientific notation. But if your problem that you're working on wanted scientific notation, you could easily move that decimal 2 places to the left and then write your scientific notation. If it specifically says write your answer in standard form, then that's what you have to do. If it specifically says use scientific notation, then leave it in scientific notation. But on a number like this that's very small, most of the time we wouldn't do that anyway, unless it really specifically said leave it in scientific notation. So 9 through 29 odd, you guys are able to do. That's the majority of the homework assignment at this point.